Yeah, this one, torsion link, or you some also called it as an oleo strut, torsion link, torsion strut, oleo link, olean strut, all are the different names. So let's start it. Create new project. From here, start this part design. Its dimension, thickness, and material are according to the requirements. How depend upon load factor and load carrying by the aircraft, which type of aircraft it is, and all other factors. So today I am going to just making a shape like this, or and not taking any specific dimension, which is as dimensions and thickness, all other things are dependent upon lots of factors. So for that we need an aircraft, which kind of aircraft it is, how much load it is taking, at what speed it's touched down the ground, and what is its wing loading and all other factors. So I am just going to make an strut with random dimensions. Okay, here first I will take a polyline so that I don't have some breaks in it or joints. I'm just making an outer outer profile of the polyester. After that we will make it clear or horizontal, horizontal, vertical. Set this one vertical, vertical, and vertical. I have done a mistake here, so I will remove it. Take in a polyline here straight, and then this bend. Okay, but I guess it would be moving. Yeah, I have to fix these 2 points together, this one and this one. This is the outer profile of that polyester. I guess I should take, you was thinking of I should take it like this, but I will make it clear afterwards. Let's start dimensioning it. So this line be 30 mm. Okay, speed 20, 20. Okay, these two connected. I'm sorry, my mistake. Zone to fit. Okay, now I'm going to take an central distance from this point to this point. Let it be 100. Okay, yeah, this shape is going much. Now I will take this as 15 mm. Okay, this one also 15 mm. Okay, This one would be 10 mm. Let it be. And similarly, this distance would also be, let it be, and make it verticals like this. It would be like this, as this one is at other end, so that other one placed here and make it straight to this. I don't need this right now. There are 3 degrees of freedom. Let me check these three. So I will fix this to this as 50. Okay, and now two left, these two. Let me fix this distance to be, let it be 40. As I earlier said, dimensions should be placed such that it is clear and does not mix up with other dimensions. This is 100. Now to the length. Okay, 1 degree of freedom. That is this one. It means it is moving like this. So let us fix this distance. Let it be one only. Now it is fine and fully defined, all green. Update and close. Here I got an outer profile of this dot, like you can see this one, this profile. Okay, next I will pad it up to 20 mm in symmetry. Okay, now what next? I will make this face shape. No, not this face. Only this edge. I guess I have 13, 30 now. So 14. First, I will make a sketch on this face. That would be a rectangle. Cutting it out, making some dimensions here. It was 30, so let it be page 15, or I guess 20 would be fine, and distance would be 10, symmetric. This was 20 now. This distance would be not, or this one was 20. So let it would be less than 20, let it be 15, fine, and taking it along with this, that is I guess 40 we choose. Yeah, okay. Okay, now it is fine. Clear dimensions. We got it close. Then pocket. I will pocket through all. Now I have a pocket like this. Okay. Now it is a curved section. I am taking this edge, applying fillet. Okay. 13. Similarly here, fillet. 13. Similarly here, fillet. 13. I guess I have to decrease this fillet. Select this edge, fillet. Okay, this fillet would be here. We can see this. Shit, got zoomed a lot. Like this, we get this. We can also increase fillet a bit more. I guess 10. No, let it be 9 only. Okay, now on this face I will sketch a circle, a smaller circle like this, which would be 0, and this horizontal distance we will take 29. It is showing it was 40. No, let it 30. Okay, now but left radius of the circle, let me give radius also. First let it be 5. and then I can close. Now from this sketch I will again make a pocket through all. Okay, here you can see I will have this. It is very close to this space, so I will change a bit, but I will increase this distance from 30 to 32 mm. Okay, close. Now you can see it is fine. We are just making a rough sketch, so it is fine here. Now, but here, this one, this sketch, fillet B9, and similarly at this edge, fillet 9. In CAD it would be different. We can make a sketch like this, and again this here we have a circular shape, perfect circle, but for now we can use this here circle. Okay, we have to manage this circle alongside. Okay, this point with this central axis here, this should be 0, and distance of this, let it be 52 only, and the radius which we are left with would be 5 only. Now it is fully defined, all the dimensions are clear and given. Close, make it a from this side sketch also, make a pocket through all. Okay, now we got a shape and size similar to that. Now what we have to do, taking this plane again and sketching over it, I am making these grooves to reduce this reduce the weight of the component. For that I am taking a polyline from here to here, then here, and here. Okay, we can have this shape. Here it would be load, so thickness should be more here, more load, so that it do not buckle or fail from this side. That's why I'm taking it like this, not take more curve. And a sharp edge also take more load, so I will make it a curve by using our fillet command. This and this, here it go, this and this, this and this. Okay, we have fillets. We can apply radius to these fillets. Point for showing, let it be 1, or we can choose 1.5 also, make it much permanent. Okay, I'm just giving this dimension, making it vertical and taking only another dimension which is from here to here. It would be 18. We can change it to 20. Let it, yeah, 20 is fine. We don't need any much. We can change this one to 2 also. Yeah, it is fine. Looking good. If I want to make it a fully defined sketch, I have to give dimensions of this point also, like this. Let it be what it comes up, as it is looking good. I don't need much modifications in it. Okay, still 4 degrees of freedom are there. Okay, need to fix these radiuses. Radius, take it whatever it is coming, or fine. Whatever it is coming, or fine. Still, uh, still it can move. So I am fixing the distance between these two, and horizontal distance of this. No need to give this distance. One is 1 degree of freedom is left. Okay. With this sketch, I will pocket up to 5 mm only. Okay. Then selecting this pocket and making a mirror around this plane. Okay. Now you can see a similar pocket has been made on the other side. Okay. Now what next I will do to reduce much more weight, taking this plane, this face as a plane, and making a circle here just to reduce weight. I am removing material from this component which is excessive and I don't need much of that material. Okay, taking dimensions, horizontal dimension of this point from this, let it be whatever it is coming here, as I don't have exact dimensions or something. Let it be 7 only. You can also make another circle here to reduce a little bit more weight, but it's not that required. We are just making it so that we can reduce some more weight of the component. And that section which we pad this section is also done for the same purpose. Take it here. Then again that vertical dimension. Okay, as we are assuming all the dimensions, so need not to check out what what dimension we are giving. But when we are designing an original component with this, we have to very much careful with these dimensions. I i must mention very much again, as precision is the key to success, and for all it will all the lives of 2,000 people sitting in the plane will depend on this component while landing. So make another CAD. Okay, so we are done. I guess this mirror which I took 5 I can take it as 6 also. Okay, and mirror I will remove. Okay, then this pocket again, mirror about. Okay, fine, got it. I like this. Okay, this is what we get. An oleo strut or a torsion link, torsion strut, whatever you want to say. This one is similar to this one. I didn't make a hole here when I made this in CATIA. It has a proper dimensions during this section is made in CATIA when the whole section. So this is also same. This distance is bit smaller in this as we have no dimension and just assuming dimension. So when we have this, we have all complete dimensions. We would have a much proper shape and much proper. We must have this a bit apart from these two, much longer, and maybe this could be much thicker as all these dimensions and requirements are based on the aircraft we are going to fit this part in. Here we have all the this all structure. Coming classes we will do other parts of the landing gear which are here in these all parts will be completed during this upcoming classes, maybe one or two a day. Someday only one part and someday it could be two parts. First we join make this, then next upcoming classes there would be other parts also of the landing gear. Thank you.
Thank you, sir. Thank you.